Tapos I'm going to share my my PowerPoint. Okay, so pag nag-work na kayo sa industry, probably yung makikita yung application ng filtration sa wastewater, ano? So generally yung wastewater ini-filter siya, ano? Kasi parang meron atang, I'm not really familiar with the laws. Mas siguro mas familiar pa kayo sa akin, ano? So basta pagkatapos ng, 'di ba, you have the wastewater treatment facility, ano? Tapos yung kasing napasukan ko, yung Wyatt, yung wastewater namin parang relatively mataas yung solid component niya. So pinifilter, ano? Probably yung makikita yung application ng filtration pag nag-work na kayo sa industry. So let's try. First, we're going to discuss the different types of equipment, and then we'll be calculating problems, ano? The usual. Okay, so this is the Buckner Laboratory Filtration System. Hindi ko alam kung nakagamit na kayo ng Buckner panel. Ito yung ceramic na parang cylinder yung shape, no? Na generally ginagamitan siya ng water pressure to suck the filtrate, no? Nakagamit ba kayo ng ganito? Yung kinakabit sa gripo o kaya sa vacuum filter? Nakagamit kayo ng ganito sa lab? Well, anyway, ito bali yung yung panel niya, no? Yung Buckner panel. Tapos ayan, may butas-butas yan dito. Tapos dito nilalagyan niyo lang dito ng filter paper. So yung filter paper hindi niyo pinofold, just place it on the top of the holes, no? So yun, upon filtration, magkakaroon kayo ng deposit ng solid. This is the filter cake, ano? Tapos this is the slurry solution. So kung natatandaan nyo pa yung filtration process, sa umpisa, mabilis siya. Pero as time passes by, pag may nag-deposit na solid, bumabagal na siya. Kapag nakapag-filter kayo sa Gen Chem Lab, di ba, halimbawa, isang oras pa lang, tapos yun na yung gagawin, mag-filter na lang kayo, no? Tapos kita nyo naman, ang bilis naman ng filtration sa umpisa. Maaga tayo makakauwi nito. Pero after 1 minute siguro, makikita nyo patak-patak na lang yung filtration, ano? So bumabagal pag may solid deposit na. Okay? Then that's the reality. As time passes by, bumabagal yung filtration rate. So this is true for constant filtration process. Yun yung i-discuss natin, ano? Yung constant filtration process. Okay. And then we have this second type of filter, the bed filter. So yung bed filter naman generally ginagamit naman to sa halimbawa you wanted to produce potable water from oceans, from seas, halimbawa Singapore, di ba sa Singapore wala silang makuhang groundwater eh. I don't know, siguro malalim o hindi maganda yung groundwater. So generally, ang ginagawa na lang nila, nagre-reverse osmosis sila. So yung prior to reverse osmosis, they need to filter the seawater. Kasi may mga buhangin yun, di ba? May mga twigs, etc., etc. So yung bed filter naman, generally it uses pebbles, no? So may maliliit na pebbles, halimbawa sand, pwede rin. So you have fine particles, then coarse particles. Ito yung pebbles, ano? And then you're going to filter the seawater, no? Or the inlet liquid. No, before it goes in the reverse osmosis chamber. It's the bed filter. Okay. So what we're going to solve later, no, is problems regarding frame and plate filter press. Ito meron tayo sa MCL nito, yung frame and plate filter press. So I hope pag bumalik na kayo, sana makabalik na kayo may babalik na kayo sa laboratory, this next term, hopefully. So sana magamit ko tong frame and plate filter press, So kaya frame and plate kasi meron siyang dalawang important component, the frame and the plate, no? So, yun, may dalawang ano no, component, the frame and the plate. So, I have the actual picture right here. So, ito yung frame, siyempre, ito yung plate, no? Ito yung plate. Yung plate, siya yung merong filter cloth, no? So, ito yung nakaka-filter, no? Tapos ang purpose naman ng frame, basically dito muna pumapasok yung liquid. So pagpasok dito ng liquid, lulusot yung slurry, yung slurry, ibig sabihin liquid na may solid. So lulusot dito sa filter yung liquid, tapos may iwan yung solid dito sa frame. Na-imagine nyo ba? So parang may opening yan dito sa taas, doon pumapasok yung slurry. So under pressure yon, mataas yung pressure, kaya yung liquid lulusot dito. Tapos magdi-deposit yung solid dito. No? So, ang operation niyan, pag puno na to ng solid, you're going to stop, and then pwedeng manual na iipod nyo yung frame at saka plate para matanggal nyo yung solid. So, in some process, yung solid yung product. Yun yung pwedeng ibenta, no? So, in some process like sa wastewater, yung solid na puproduce sa amin, no, sa Wyatt dati, kinukuha siya ng third party tapos sila yung nagdi-dispose. Kasi basically parang waste din siya. Tapos yung lumalabas na liquid, diretso na siya dun sa tinetest na lang tapos diretso na dun sa meron kaming katabing creek, no, dun sa Wyatt, diretso na dun sa parang kanal or creek, no? So ganun yung process. Pag generally pag nag-industry kayo, magagamit na naman 'tong lahat ng pinag-aralan natin, no? Pag tiningnan niyo, may mga naman yan may mga plant design naman yan, ano? So yung mga napasukan kong companies, halimbawa sa Honda, yun, may plant design siya. Sa Wyatt, may plant design din siya. So makikita niyo naman diyan kung paano din-design yung mga equipment. Yung mga calculation natin dito, makikita niyo doon sa plant design, no? Ganun naman yun. ang ano lang nga talaga, I don't know. Pero sa nung college kami, nung nag-plant design kami, siguro mga 100 to 200 pages din lang. Parang thesis din lang, 100 to 200 pages. Mga ganyan kakapal yung plant design namin. Nung nag-work na kami, actually, yung mga plant design, ganun din, mga 100 to 200 pages. I really don't know bakit sa MCL umaabot sila ng 500 pages yung mga plant design nila. Anyway, siguro mas kompleto. Okay, so let's continue. So basically ganito yung operation, itong kulay orange, ito yung frame, no? So doon papasok yung slurry, no? The slurry enters the frame from the feed channel. So ito yung usually pinapump yan, yung slurry pinapump. You have a pump, tapos pinapump siya dito papunta dito sa frame. So pagpasok dito sa frame, this is the filter. This is the frame, tapos this is the plate, This is the plate part. So as you can see, papasok yung liquid dun sa lalampas siya dun sa plate. Okay? Sa filter. Tapos magdi-deposit ito yung solid. So dire-diretso lang, So filtrate drains and escape from outlet in the plate, leaving solid to form a cake. So magpo-form yung cake dito sa frame. Na-imagine nyo? So mamaya we're going to watch some YouTube. Most probably ma-imagine nyo naman, Okay? So medyo mas malabo yung nasa gene couplets, kasi black and white. Pero basically, paano ba to? ito pa rin yung liquid natin, So probably this is the frame, This is the frame. So pagpasok dito ng frame, you have on both sides, you have the plates, On both sides you have the plates. So papasok doon yung liquid, may iwan yung solid dito sa gitna. Magdi-deposit dito yung solid, And then you're going to collect the filtrate on the bottom of the plate and frame filter press, Nasundan? Pasok yung liquid, pasok sa frame, tapos lalampas siya sa plate, no? Tapos magko-collect yung filtrate dito sa ilalim. So that's how you generally operate a filter press, ano? In some operation, you need to wash the solid kasi yung solid yung product. So pag washing, generally pag washing, dun lang sa isang frame pumapasok tapos dun sa isang frame lumalabas. Ganito, ano? Yan. As you can see, isang frame lang yung pinapasukan tapos yung isang frame nilalabasan, ano? So somehow parang pag washing na, this is the washing operation, ano? So meron tayong tinatawag na non-washing plate. Okay? Merong non-washing plate. So kumbaga, yung washing isang direction lang siya, hindi siya nagsasalubong tapos lalabas siya dito sa ilalim nung plate, ano? So sa ganun, ano? Papasok siya dito sa isang side tapos lalabas siya dito sa isang side. Okay? So mamaya makikita nyo, mas mabagal yung washing. Yung rate ng washing mas mabagal kaysa dun sa filtration process. Mamaya makakalculate tayo ng time, ano? So makikita nyo yung formula dun sa washing times 1/4 nung filtration rate, no? It's because yung originally yung filtration, you are using 2 plates. Pero pag washing na, you're just going to use 1 plate. So mahahati yung area. Ganun yung ganun yung explanation nun. Bakit mas mabagal pag washing. Okay, so probably let's try to watch this YouTube. Pag hindi natin natapos today, meron pa naman tayong Wednesday, ano? Friday is a holiday. Can you see the YouTube? Can you hear the sound? Okay lang ba yung audio?
Opo,
Yes po, sir.
So this is the plate and frame filter, ano? So ayan, simula ng filtration, papasok na yung slurry. And then as you can see, the solid will deposit on the on the frame. Tapos yan na yung filtrate, ano? So ayan, may solid na yung I think this is the washing part, ano? Ito na yung washing. So as you can see, the system is wash. Yung mga solid dun sa tubo, yung mga dumi dun sa tubo natatanggal din, ano? Tapos the last part is the cleaning, ano? This is the removal of the solid deposited on the frame para magamit siya ulit. Ano? So basically binubo ka lang. So that's why filter press kasi pinipress siya. Tapos ino-open para malaglag yung yung cake. Most probably you will see this pag nag-work na kayo sa industry. You will see one. Actually meron tayo sa MCL. Hopefully magkaroon kayo ng Chem-Eng Lab. I think Chem-Eng Lab kayo next term, ano? Okay, so after the plate and frame filter press, the next most common type of filtration equipment is the lip filter, no, the lip filter. So basically ano lang to, tangke, no? It's a tank. Tapos inside the tank, you have lip filters. These are lip filters, ano? Basically yung lip filters, cloth lang sila, tapos sa loob may metal. So as you can see, yung operation niya, papasok lang yung slurry, papump lang yung slurry dito sa loob ng tangke. Tapos walang ibang outlet. Ito lang yung outlet niya sa taas. So before you can go to the outlet, you need to pass through the cloth with metal support. Ano? So lulusot lamang dito yung liquid, 'di ba? Pag this is under pressure, if the slurry is under pressure, lulusot lang yung liquid dito sa dito sa cloth. Tapos, yun, there's no way to go out but to pass through these outlets, filtrate outlets. So, ang difference ng, halimbawa, mamaya magkakalculate tayo ng mga problems sa lip filter. Ang difference nito, hindi nagdi-deposit yung solid dito sa filter, dito sa cloth. No? So, yung pag nag-wash, during the washing operation, hindi bumabagal. Wala tayong times 1/4. As is lang. Hindi bumabagal yung filtration process during the washing, no? So let me show a lip filter para mas ma-imagine nyo from YouTube. Can you see the YouTube right now? Can you hear the sound? Okay lang ba?
Step 1. Remove the plastic wrap from the filter. Open the zip.
So this is the lip filter. Can you see the lip filter?
Place the sweetland leaf filter press inside the press cover.
So you have several of these inside a lip filter. Imagine nyo.
Step 3. Pinch the edges together to pull the zip around the plate. The zip will be relatively stiff.
Ganyan yung itsura ng lip filter, yung filter niya sa loob.
Step 4. Pull the material down the spout from the top.
Yan. So, dyan lalabas ito.
Secure the cable tie around the
filtrate outlet.
You are now ready to install your sweetland leaf filter press back into position.
Imagine nyo how this equipment work. So basically, yung pinakita ko sa inyo na sa YouTube, you have several of the lip filter installed inside the tank. So when the slurry goes inside the tank, it's under pressure. So there's no way for the liquid to get out of the tank. It needs to pass the cloth before it gets out to the filtrate outlet. Okay, so notice that hindi yung solid generally hindi siya magdi-deposit dun sa cloth. Generally nandito lang yan sa ilalim ng tank. Kaya mamaya makikita niyo yung formula ng lip filter iba dun sa formula Sa washing, iba dun sa formula ng ng frame and plate. Do you have any question? Okay pa ba? Interested pa ba kayo sa mga equipments? Actually, syempre, sa industry, makikita nyo pag nasa industry na kayo, makikita nyo, doon talaga napoproduce yung wealth, no? Nung nasa Wyatt pa kami, merong bulletin board, tapos nakalagay doon kung magkano yung napoproduce naming product per month. Generally, nung nasa Wyatt pa kami, relatively, pag tiningnan mo yung planta, ang liit-liit lang, tapos parang 300 lang ata yung empleyado, kasama na yung sales, kasama na yung mga nagbebenta. We're producing, parang ₱1 billion worth of product per month, no? 2007 pa yon, So, nung umalis ako, nag-expand sila parang dinoble pa nila yung capacity. So, ganun kalaki actually yung napoproduce ng na product nung mga planta, no? So, I hope you're still interested with this equipment, Sandali. Do you have any question?
Delivery po? May babayaran?
Do you have any question regarding the filter? Okay, kung wala, let's proceed, no? Next is we have the rotary drum filter. So, yung rotary drum filter naman, may vacuum, So the vacuum, merong vacuum, meron kang nagro-rotate na drum, tapos merong vacuum. It sucks the liquid on the tank. Meron kayong tank dito ng slurry, tapos ito under vacuum, so it sucks the liquid, So as you can see from the illustration, the solid will deposit on the drum, May iwan doon. Tapos ito umiikot itong drum. Tapos on the other side of the drum, merong knife. So the knife will remove the deposit solid, Ito na 'yon, So on some area you have drying, you can blow air, tapos on some area you can spray water para magkaroon may washing kayo, tapos you can also dry it again. So drying, washing, tapos drying, So ganito yung illustration ng rotary drum filter. Question regarding rotary drum filter? So I hope manood ulit tayo ng manood ulit tayo ng video para mas ma-imagine niyo.
You can't expect your team to manage work with this. With Monday.com's flexible management system, however.
Okay ba audio? Okay ba YouTube? Okay kita nyo?
One of the most common needs in today's manufacturing environment is sludge dewatering and meeting discharge limits. Alar's AutoVac system effectively removes solid particles from the sludge, producing dewatered dry waste. Typically, this waste is disposed of at a local landfill without further drying. The Alar AutoVac filtering system is skid-mounted, pre-piped, and pre-wired for easy installation. It is offered both with semi-automatic and automatic modes of operation. This design works with virtually any industrial waste, such as coolants, cleaners, and process water. The operation of this Alar Autovac filter is semi-automatic. The operator charges the pre-coat tank with filtering media called diatomaceous earth, or DE. The DE slurry overflows into the filter pan, and the vacuum draws the DE filter media onto the cloth. This pre-coat operation takes about 15 minutes and is performed with each shift, building up a 3-inch tape. The water passes through the DE media and out a hollow shaft. This DE media is capable of removing particles as minute as 1/2 of a micron. That's 1/2 of 1/1000th of a millimeter. Filtering is performed in much the same manner as pre-coating. The wastewater is pumped into the pan. The level controllers located within the pan maintain a constant liquid level, eliminating the need for operator attention. The vacuum draws the liquid through the DE media and out the shaft. The solids are trapped on the surface of the diatomaceous earth, where they are air dried for 2/3 of a revolution of the filter drum. This process removes virtually all of the free moisture by drawing an amazing vacuum of 26 inches of mercury. These solids are continuously removed from the surface of the cake by an extremely durable stellite knife blade, advancing with lathe-like precision, leaving a clean surface as the drum re-enters the sludge. The Autovac is self-cleaning with every revolution, which prevents blinding or clogging and provides rapid filtration and extremely high filtrate clarity. After a long day of continuous use, the DE will be exhausted, and the Autovac is now ready for quick and easy cleanup. Cleanup is performed by activating the water nozzle on the Autovac spray bar. The cleanup water is minimal and is filtered with the next batch. With an automatic option, the Autovac can repeat the pre-coat process and go back online or shut itself down. From start to finish, the Autovac is designed for ease of operation with minimal manpower required, providing remarkable results. The Alar Autovac substantially reduces operation and disposal costs by typically achieving reduction in volume of 90 to 95% and producing landfill-ready solids. For a no-cost, no-obligation wastewater filtration.
Do you have any question regarding the rotary filter system? Question kayo dito? Imagine nyo ba to? So, merong slurry. Nakita nyo, meron pa silang nilalagay, diatomaceous earth. No? You're familiar with diatoms? Narinig nyo na ba yung diatoms ng high school? These are small organism in water. So, hindi ko alam kung meron din sa mga tropical country or sa temperate country lang. Pero basically, yun, pag they can collect it from seawater. Tapos it is used to aid filtration. So aside from the cloth na nakalagay dun sa rotary drum, they put a layer of diatomaceous earth over the cloth, So mga filtration agent, Tapos merong vacuum, it sucks the slurry, Tapos the solid in the slurry deposit on the drum. So, yun, may drying at saka pwede rin may washing. Tapos at one portion of the drum, kita nyo naman may knife, So the knife remove the solid. Question? You have any question regarding rotary drum filter? Okay, so yun. Filter media, you have different kind of textile or cloth materials. Tapos, aside from the cloth, you also have the filter aids. This is the diatomaceous earth. Ano? Diatoms. Diatoms are living organism. You can find this in oceans. Pero pag kita nyo naman kayo na parang clay na rin lang siya, no? Parang clay. Ginagamit siyang filtering aid. Okay, let's go to the mathematics of filtration, ano? So ang pinaka-basis ng ating formula for filtration is the filtration theory or the root equation. So ito yung I don't know, no? You can find this on on our handbook, page 18.83. So chapter 18 is filtration, from the 8th edition. So this is the Hagen-Poiseuille equation, I don't know how to correctly pronounce this. Probably Pois. Parang senti-Pois, So Hagen-Poiseuille equation. Sabi ng iba pansol daw to, pansol. Hagen-Pansol. Punta ba kayong pansol? Okay. So basically this equation, you can see itong dv theta, yung b, yun yung ditong dv d theta, parang ito yung filtration rate, yung napoproduce na filtrate b dv per unit time. So dv d theta. Okay. Yung filtration rate, as you can see from the Hagen Poiseuille equation, is directly proportional sa pressure. Diba? Common sense naman yun. Diba? Pag mas mataas yung in-apply mong pressure dun sa liquid, mas malakas yung filtration rate. No? Ito yun, pressure. Directly proportional siya sa pressure. And also directly proportional dun sa filtration area. So pag mas malaki yung area, yung filtration area, mas mabilis din yung filtration rate. Diba? So directly proportional siya sa filtration at saka directly proportional sa filtration area. Yung nasa ilalim, ang unang-unang variable dito, itong mu, this is the viscosity, no? So this is the viscosity mu. Tapos yung alpha naman, ito yung resistance ng cake, no? So dalawa kasi yung nagko-cause ng resistance, yung solid, yung or cake, at saka yung filter cloth, no? So that's why meron tayong alpha, ito yung resistant nung solid cake, tapos yung R, ito naman yung resistant ng cloth. Okay? Kaya R resistance, no? The cloth resistance. Ito naman yung sa cake, alpha. So i-multiply niyo lang siya ng W. This is the handbook, Yung W, basically yan, weight of the cake solid per unit volume of filtrate, no? So para ma-convert lamang yung resistance to cake solid, So yun yung W. Weight of cake solid per unit volume of filtrate. And then again, yung B, volume na naman yan. Tapos, directly, syempre, pag marami na kayong filtrate, yung B, bumabagal na yung filtration, kaya inversely proportional siya. And again, you have another unit, another area. Here, right here, So this is the Hagen-Poiseuille equation. Okay? So, nasa handbook naman yan, pag merong filtration problem sa board exam, so punta lang kayo sa chapter 18, hanapin nyo itong Hagen-Poiseuille equation. O kaya, paki-mark na lang to sa handbook, Paki-check kung meron sa 9th edition. So most probably meron din yan. Chapter 18. So let's derive the working equation for filtration problem. So we'll start with this. So as you can see, basically ang gagawin lang natin, nasa iyo pala yung
Drawing tablet.
Drawing tablet. Dali lang. Dali lang, pinapakabit ko lang yung drawing tab. Basically, yung Hagen-Poiseuille or yung root equation or yung filtration theory, kunin niyo lamang yung yung reciprocal niya, Kunin niyo lang yung reciprocal. So Diba ito yung nakasulat doon sa kabila ano sa handbook natin. So you have 1 over A tapos dB d theta. Theta is the same as time ano. Tapos you have P all over, nakahiwalay dito yung ano no, yung viscosity. Tapos you have alpha CS. Actually CS is W ano. What else? And then you have R right there. Lang. This is alpha CS times B over A, ano? Times B over A. CS or W? B over A. So basically, ang ginawa lang natin is we get the reciprocal of this equation. So transpose nyo muna yung A. So it will become P over A. No? Tapos you just get the reciprocal. Yung theta naman, ginawa natin T. So that's why you have dt, d theta. Tapos kinuha natin yung reciprocal. No? Imagine nyo ba? So tinranspose ko yung A sa kabila. Na-imagine nyo pagka-transpose. Tapos kinuha ko yung reciprocal. So you have something like d theta dB. Tapos sa taas, you have the density. And then you have alpha CS B over A plus R parenthesis divided by PA. Ito na yung reciprocal niya. Ano? Tapos pag ginawa ko itong dalawang terms, so you will have mu, ito yon, mu times alpha, so ito yon, times C sub S, ito yon, times B, ito, tapos you have 2A, so you have A squared. Yung pipinaltan lang ng delta P, negative delta P. This is the, kasi kanina nagsimula tayo sa handbook, tapos itong nakikita nyo dito sa gene couplets na to. Pero basically parehas lang yan, ano? Okay. Doon naman sa second term, you have R, no? So you have mu R divided by PA. So ito yon, mu R divided by PA. Can you follow? So medyo nagbago din yung R. Sa handbook, small letter R lang. Kay gene couplets, RM na siya. Resistance of the media. Kaya sa handbook, R lang siya na maliit. No? Tapos again, yung P, naging negative delta P. Tapos times the area. Can you follow? So it's just relatively the same. No? Konting bago-bago lang ng mga variables. Ng mga name ng mga variables. Pero these are the same. So what we're going to do is we're going to let KP equal to mu times alpha times CS times A squared divided by negative delta P. So ito yun, ano? Tapos, we also let B, okay, another one, let B equals to mu RM A delta P. Ito, let B is equals to mu RM A delta P. So in short, we're going to reduce this quite complicated equation into dt over dB is equals to KPB plus B. Tapos, integrate natin yung equation. How do we integrate this? Transpose natin yung dB sa kabilang side. So pag tinranspose natin yung dB sa kabilang side, you will have T is equals to, nandito yung dB sa kabilang side, you will have Kp. So anong integration ng BdB? So you will have B squared divided by 2 plus BdB. So BdB will become BB. So ganun lang, upon integration. Tapos halimbawa, gusto nating magkaroon tayo ng linear equation. How do we convert this to a linear equation? We just transpose B to the other side. So pag transpose nyo B sa other side, you will have this. TB is equals to KP over 2 times B plus B. So ito yung gagamitin nating equation to solve the problems. So as you can see, meron tayo dito makikita nyo, meron tayong volume versus time concentration. Kailangan nyo lamang kunin yung constants, yung Kp at saka yung B ng filtration system. And how do you get the constant? You need to use the property of the liquid, viscosity niya, yung concentration ng solid, C sub S, at saka yung mga resistance, ng solid. And also, of course, the pressure and the area of the filtration system. You got the idea? So basically, ito lang yung formula natin. T over B is equals to Kp over 2B plus B. Okay pa ba kayo? Sige, mag-solve na tayo ng problem. Ano? So this is example 14.2-1, evaluation of filtration constant, no? For constant pressure filtration. So yun yung ating isang solve. Ano? Constant pressure filtration. Most of the filtration is constant pressure. halimbawa yung open lang sa atmosphere, that's constant pressure, di ba? Yung ginagawa natin sa lab, that's constant pressure. So data for laboratory filtration of calcium carbonate slurry in water at 298.2 Kelvin, 25 degrees Celsius, are reported as follows at a constant pressure delta P of 338 kilonewton per meter squared. That is kilopascal. Ano? So the filter area of the plate and frame press was A is equals to 0.0439 meters squared. And the slurry concentration was C sub S 23.47 kilogram per cubic meter. This is kilogram solid per cubic meter. Ano? Yun yung concentration ng slurry. Calculate the constant alpha. Ano nga yung constant alpha? Alpha is the resistance of the media, of the solid. And RM is the resistance of the media. Sorry, baliktad. Ano? So alpha is the resistance of the solid, RM is the resistance of the media. Yun yung pinapahanap, no? Sa problem. From the experimental data given, where T is time in seconds, so ito ay seconds, and B is filtrate volume collected in cubic meter. Ito ay cubic meter. So how do we solve this problem? So first, you need to find K, P, and B. No? So ang gagamitin nyo dito, magli-linear reg kayo, tapos gagamitin natin yung equation na T over B is equals to KP over 2 times B, no? Plus B. Ganun. Ano? So, as you can see, ito yung magiging X, tapos ito yung Y natin, no? So, yung slope niya would be equal sa KP over 2, tapos yung Y-intercept would be equal to B. Tama? So, halimbawa, yung B, di ba kanina dinefine natin siya, equal siya sa viscosity times yung RM times yung divided by nung area divided by nung pressure. Ano? So given yung viscosity nasa handbook naman yan, pero ibibigay ko naman sa inyo pag nag-exam kayo. Tapos yung area, given naman siya, ito 0.0439. Yung pressure, ito 338 kilopascal. Tapos yung B, makukuha nyo dito sa linear regression. So you can solve for RM. Ganun din sa Ganun din sa alpha. Di ba may equation naman tayo ng KP? So yung KP, mu CS B, mu CS tapos B delta P. Anyway, hindi ko memorize. Tingnan na lang natin mamaya. May A pala dito, may A squared delta P. So, parang ganyan, ano? Tapos alpha. Ganyan yung KP, ano? So, that's how to solve this problem. So, the first thing you need to do is mag-linear regression kayo. Mag-linear regression tayo. So, for example, yung X natin would be itong mga B. So, type pasok nito sa calculator nyo. Marunong pa kayong mag-linear reg sa calculator. So, mode, kung naka-class kayo, mode, tapos pindutin nyo lamang yung 6, no? 6. Tapos itong B, ito yung magiging X. Ito yung X natin, ano? Ito yung X natin. So as is yan, cubic meter yung unit niya, ano? Tapos yun namang Y, yung Y natin ay T over B. So for example, ang unang Y natin ay 4.4 divided by 0.498 times 10 to the minus 3. Ano? And so on. Halimbawa, 9.5 divided by 1 times 10 to the minus 3. Kindly get your calculator tapos hanapin natin yung slope. So medyo madami. We have 10 pairs of data. Kaya nyo? Ayan. So sa board exam, maraming linear regression problem. Dapat marunong kayo mag-linear reg sa calculator. So mode 6, pasok niyo yung mga data number 2, no? Yung X muna, 0.498 exponent minus 3. So 10 data yung papasok niyo na 1 exponent minus 3, 1.501 exponent minus 3, 2 exponent minus 3. Let's be careful, ano? 2.498 exponent minus 3. Okay. 3.002 exponent minus 3. Kailangan medyo matyaga pag KMN. 3.506 exponent minus 3. Yan yung tinuturong values ng ano eh, ng engineering, ano? Dapat matyaga ka. 4.004 exponent minus 3, 4.502 exponent minus 3, and then 5.009 exponent minus 3. So check nyo, dapat naka 10 data kayo na ipasok. Tapos yun namang T over B. So let's start with 4.4 divided by 0.498 exponent minus 3. Tapos 9.5 divided by 1 exponent minus 3. 16.3 divided by 1.501 exponent minus 3. Tapos 24.6 divided by 2 exponent minus 3. Nakaapat na ako, ano? Ang 5. 34.7 divided by 2.498 exponent minus 3. It's the fifth one. 46.1 divided by 3.002 exponent minus 3. Okay. Tapos 59 divided by 3.506 exponent minus 3. 73.6 divided by 4.004 exponent minus 3. 89.4 divided by 4.502 exponent minus 3. 107.3 divided by 5.009 exponent minus 3. Okay? Sige nga, subukan natin kunin ang so AC nyo, pindutin nyo yung AC, tapos operation, OPTN, press OPTN, tapos number 3, regression calculation. So check nyo. Yung R should be 0.99, ano? Tama ba? 0.99. Tapos anong, what A did you get? Ano ang Y-intercept? Anyone? Ano bang gumawa? Yep, very good, Gio. 6,783.75. I also got that one. Ano? 6,783.75. So yun yung value ng B. Yung y-intercept yun yung B. Tapos yung slope nyo naman, 'di ba, you get something like 2,884,955, no? So yun yung equal yun sa KP over 2. So pag minultiply nyo yun ng 2, yung slope times 2, you will have the KP, no? So that's approximately yung 2,884,000, that's approximately 3 times 10 to the 6, approximately 3 million, ano? Approximately 3 million yung KP over 2. So times 2, 6, no? So 6 million, 6 times 10 to the 6 yung KP. Napalabas ba yon from your calculator? So, yung B, kamukha nung nakuha ni no? Mga around 2,783, 384, no? Ito yung B. This is also the y-intercept. Tapos yung slope naman, this is equal to KP over 2. So this is approximately equal to 3 times 10 to the 6, or 2.9 million, ano? 2.8 million. So round off na lang natin ng 3 million. 3 times 10 to the 6. So ibig sabihin nun, it follows that KP is approximately equal to 6 times 10 to the 6. Question? Yep, 67. Ay sorry, 67 pala. 6784. Ano pa? Ano pang question? Any question before we proceed to the next step? So we're able to get KP and B. So medyo masikip ano. Punta ako doon sa susunod na page. So yun, recall lang natin yung ito yun ano, yung KP over 2 yun yung slope ng line. Yung B ay yung y-intercept. Ano? Ito yung pinlat natin, T over B at saka B. Okay. So ito na yung value ng KP natin, 6 times 10 to the 6. Anong unit nito? Anong unit ng KP? Remember, ang KP ay slope. So pag slope, ano yan? Rise over run, di ba? Rise over run. So ang rise natin ay T over B. Tapos yung run natin ay B, yung X. No? So ang unit ng KP, yung T ay seconds, tapos yung B, yung volume, cubic meter. Tapos yung B again, cubic meter. So ibig sabihin, therefore, ang unit ng KP natin ay seconds per meter to the 6. Ito, ano, itong 6 times 10 to the 6 ay seconds, tapos meter to the 6. Okay? You need the units, ano? Kasi, yun, isa-substitute, di ba? We let KP equal to mu times alpha times CS divided by A squared divided by delta P. So lahat naman to nandoon sa problem. No, you just substitute. Aside from the viscosity, actually you can kaya ganito kasi yung problem kay Gene Copley, dapat kaya niyo nang kumuha ng viscosity from the handbook. 'Di ba? Tinuruan ko na kayo ng ano. Pero syempre hindi muna natin i-recall kasi masyadong challenging naman 'yun, ano? So in the exam, bibigay ko sa inyo yung viscosity ng liquid, no? So ito yung viscosity ng liquid, it's 8.937 times 10 to the minus 4. So ang unit nito ay Pascal second, no? This is Pascal second. Okay, any question? Ito yung viscosity. Tapos alpha yung hinahanap natin, yung 23.47. If you still remember, this is kilogram solid per cubic meter, no? Ito yung concentration ng solid dun sa slurry. 23.47 kilogram solid per cubic meter of slurry. Yung A, 0.0439, this is meter squared, no? Tapos itong 338 times 10 times 1,000 kilopascal kasi itong 338 So Pascal to, ano? So pag nag-dimensional analysis kayo, makikita niyo magka-cancel yung Pascal. Ano pang magka-cancel? Itong meter na to, tsaka yun, this is meter to the 5. So sa kabila may seconds, tapos may meter to, yung seconds magka-cancel out din. Ano? So ang matitira na lang dyan, meter to the 5 tapos meter. So ang unit nung alpha natin ay, may matitirang isang meter. Ito, yung kilogram kasi nandito sa side na to, kaya ito transpose sa kabila. Ano? So, squared pala to. So, squared yung meter. So, magiging 7. Ano? So, pag transpose yan, may matitirang isang meter. So, meter per kilogram yung lalabas. Okay? So, kindly get your calculator. Shift solve natin tong equation. So, I intentionally rounded off the value of KP para kamukha tayo nung solution ni Gene Copley. At least mas malapit. Ano? So, balik tayo sa mode 1 ng calculator. So, shift solve natin itong first equation. 6 exponent 6. Tapos, we have 8.937 exponent minus 4. This is the Pascal second viscosity. Alpha X, unknown. So, times 23.47. Sa ilalim, we have 0.0439 squared. Tapos, times 338. That's Pascal. Ano? Shift solve. Get the value. Yes. You're supposed to get 1.86 times 10 to the 11. Very good, Gio. Yep, very good, Paolo. Tama to. Ano? You're supposed to get the same 1.86. So this is your alpha. So ang unit ng alpha is meter per kilogram. Remember, alpha is the resistance due to solid. Yung solid na nagdi-deposit dun sa plate and frame filter. Ano? Tapos let's try to calculate the cloth resistance. So gagamitin lang natin yung equation ng beta. Earlier we defined beta to be equal to viscosity times Rm, yung Rm yung hinahanap, divided by area divided by delta P. So kita nyo, ni-round up na rin yung B. Di ba ang na-calculate nating B ay 6,784. So hindi ko alam kung paano niya ni-round up. Basta kasi may problema may problema yung calculator ni Gene Coppers. Anyway, ni-round up niya sa 6,004 yung B. No, malapit naman. Malayo man, malapit din. From 6,784, ni-round up niya sa 6,004. So gamitin na lang natin yung rounded up value niya na 6,004. Ano? Tapos we have the same viscosity, 8.937 times 10 to the negative 4. Of course, sa exam nyo, hindi kayo magra-round up ng ganito. May problema lang kasi yung calculator ni Gene Coppers. Sinusunod lang natin. Ano? Kung ano yung lumabas na B nyo, yun ang gamitin yung B. No? So, sinusunod lang natin para we'll have the same final answer. 8.937 times 10 to the minus 4. Tapos ito yung hinahanap natin, yung resistance ng media. Tapos yung A is 0.0439. Tapos 338 times 1,000 Pascal. So, solve ulit natin yung RM. Keep solve. 6,4. Alpha equal. So, 8.937 exponent minus 4. Okay. So, times the unknown divided by 0.0439 times 338 exponent 3. So, keep solve. Yan. What do you get for R? Yep. Very good, Paolo. Ano? 1.06 times 10 to the 11. No? Very good, Paolo. So that's the same as 10.63. Ano? Minub lang ng isa yung ano, no? Yung decimal place. So ang unit niya ay per meter. Bakit? Mag-ano tayo? Mag-dimensional analysis tayo. Yung B ay y-intercept. So ibig sabihin y din siya. So ang unit ng B ay T divided by B. Di ba? Ito yung unit ng B. Ang T natin ay seconds tapos ang B ay cubic meter. So ang unit nitong B ay seconds per cubic meter. This is Pascal second. Okay? Tapos ito ay meter squared, yung 0.0439 na area. Ito naman ay Pascal. So as you can see, magka-cancel out yung Pascal, magka-cancel out yung second, no? So tama ba? Sorry. This is meter squared only. Area. Meter squared only. So ang unit ng RM ay per meter. Magka-cancel out itong dalawa, ano? Itong meter squared mawawala. May matitirang isang meter. So per meter yung unit ng RM. So 10.63 times 10 to the 10 per meter. Do you have any question regarding this first example ni Gene Coppers sa filtration? Okay lang? So, formula lang naman, di ba? Formula lang naman. Magli-linear reg lang kayo para makuha niyo lang yung KP at saka B. Tapos, basically, formula lang naman. Medyo mahaba lang yung formula, pero pag formula, madali din lang naman yan. As long as you remember the formula, madali din lang. So ako, ang sinasuggest ko sa inyo, dapat talaga, para hindi nyo naman kailangan i-memorize, wala kasi itong KP at saka itong B formula sa handbook. So kailangan nyo talaga silang i-derive. So it's either mag-derive kayo or mag-memorize kayo. So kung anong mas prefer nyo. Ano? Ganun talaga. Wala kayong mapipili na madali. So it's either mag-derive kayo o mag-memorize kayo. Okay? I hope you can adjust. Okay, so let's ano. Still have time? Di pa naman tayo 11:30. Mama, anong oras? Anong oras na?
1109.
1109. Kaya pa siguro isang problem. Then we check on 1109. Kaya pa yung dalawa. Madali lang naman. Okay, so let's continue. If you don't have any question. Okay, so let's try to solve this second example. The same slurry used in example number 1 is to be filtered in a plate and frame press having 20 frames. Yung unang problem kasi, isang frame lang yung ginamit. Tapos maliit pa yung area niya. So yung sunod, yung problem, you have 20 frames and then each frame is 0.873 meters squared yung area, no, per frame. The same pressure will be used in constant pressure filtration, assuming the same filter cake property and filter cloth. Ibig sabihin, parehas lamang yung ating mga resistance, pati yung pressure natin, parehas lang. Ano? Lumaki lang yung area, yun lang yung kaibahan, lumaki yung area, filtration area. Calculate the time to recover 3.37 cubic meter filtrate. So, So in this problem, gagamitin lang natin yung na-derive nating equation, ano? Yung P over B is equals to KP times B plus B. Gagamitin lang natin 'yan. So basically itong volume na to, yan lang 'yon. Tapos we need to find the new KP and the new B. Kasi remember, yung KP na kinalculate natin dun sa example number 1, para lang yung sa maliit na area, yung 0.04 something meter squared. Eh lumaki yung area natin, ano? 20 times 0.873 na. So if you will notice do sa equation ng KP, diba? May mu, tapos may CS, tapos may alpha, tapos may area squared, no? Tapos mayroong P. So as you can see, yung KP ay inversely proportional siya dun sa squared ng area. So from here, you can deduce kung constant yung viscosity, constant yung concentration ng filtrate, no? Hindi naman magbabago yung resistance ng solid. Okay? Hindi naman magbabago yung pressure natin. We can say that KP1 times area 1 squared is equals to KP2 times area 2 squared. Ito yung gagamitin nating equation to find KP2. No? So for example, di ba tandaan niyo pa yung KP1 is 6, no, times 10 to the 6. Di ba? Ito 'yon. So seconds per meter to the 6. So i-multiply lang natin siya nung A1. I think it's 0.0439 if I'm not mistaken. 0.0439 meter squared. Tapos yun. We can calculate KP2. Tapos A2 is times 20 times 0.873. No? Squared. Yan. Check ko lang yung area. Tama, 0.0439. So yan, that's how you can calculate KP2, ano? So KP2 is, use your calculator. Basically yung KP2 yung gagamitin nyo sa major equation. 6 exponent 6. Same unit yan, nagiging seconds per meter to the 6. May squared pa to dito. Kalimutan ko ilagay. Yep, very good. I think that's correct. Very good, Paul. Okay, squared divided by parenthesis 20 times 0.873 squared 37.93. Very good, Paolo. Very good, Gio. Very good, Kissy. 37.93. Ano? So this is the same as second meter to the 6. What about B? Di ba yung B naman, ang formula naman ng B, mu RM, tapos A lang, tapos times P. No? So constant naman ng viscosity, constant yung resistance ng media, constant yung pressure. So again, parang meron tayo ditong equation na ano, B1, di ba? B1, A1 is equals to B2, A2. So yun. Do you agree? So calculate natin yung bagong B. So B1 is, ito na lang ano? Ito na lang. So B1 is 2004. Let's use the 2004 value. 2004.0439. 6,004 pala. Lagi ako nagsisix. 6,004.0439. Tapos B2. Tapos 20 times 0.873. Both of them is in meters squared. Ano? So B2 is you're supposed to get, ilan nakukuha niyo? Yep, very good job, Paolo. No, 16.09. Kasi may, that's correct. No, 16.1. Very good, Gio. 16.09. So you're supposed to get 16.09. So again, the unit for this is seconds per cubic meter. No? Tapos yun, substitute nyo dito to calculate the value of time. So time, we're going to recover 3.37 cubic meter. Okay? Yung KP natin ay sorry, may KP over 2 to ano? May KP over 2 yan. Nakalimutan ko lang isulat. So, ang KP natin na bago is 37.93 divided by 2, tapos times 3.37, tapos plus 16.09. You can do the you can do the dimensional analysis tapos lalabas na time diyan ang unit niya seconds, di ba? Kasi obviously, itong KP seconds meter to the 6 tapos multiply niyo ng 3.37 cubic meter magiging seconds meter to the 3. Pag multiply niyo ng cubic meter, magiging seconds na lang 'yon, ano? Ganun din sa B, na 16.09. Okay, so ano yung lumalabas na T? Pan calculation. Sana nakakasunod kayo. Madali lang naman, di ba? Yep, very good, Gio. Very good, Paolo. 269.61. Very good, PC. Madali lang naman, di ba? Yung una lang, yung linear regression, medyo tedious lang siya. Pero itong pangalawang problem, madali lang, di ba? So you're supposed to get 269 something, ano? Mga around 270 seconds, ano? 269.6 seconds. Any question? Do you have any question? Okay, if you don't have any question, let's proceed to the next problem, the last problem. So ito naman yung solution, ano? Pag meron kayong hindi maintindihan. Basically, kinalculate lang natin yung bagong KP, tapos kinalculate natin yung bagong B. Nagbago yung KP at saka B kasi nagbago yung area natin, ano? Ito na yung bagong area natin. Tapos sinubstitute lang natin doon sa basic equation. Tapos lumabas na yung 269.7 or 0.6, ano? Question? Okay. Doon naman tayo sa washing, ano? So kamukha nung kinukwento ko sa inyo kanina, for plate and frame, yung washing bumabagal, no? So, di ba, this is the dV/dt equation. So, the dV/dt is equals to 1 over Kp over times Bf plus B. Bf is the final volume ng filtrate na na-recover, ano? So, pero yung washing, i-multiply nyo siya ng 1/4. Bakit 1/4? Yung explanation nito sa libro, pwede nyo daw isipin na empirical to. Empirical yung equation. Tapos yung another explanation nito, kasi di ba A squared, tapos nabawasan yung area nyo ng isa na hati. So 1/2 times 1/2, 1/4. Yun yung isang explanation. Kumbaga parang nineglect yung B. Nineglect lang yung, usually kasi masyadong maliit yung resistance nung plot nung filter media compared dun sa solid. Yung solid talaga yung mas mataas ang resistance. Kaya yun yung explanation nito, bakit may 1/4 dyan. it's 1/2 of the area. So 1/2 squared is 1/4 from KP, ano? Tapos nineglect yung effect ng B. Or another explanation is empirical yung rate of washing equation. Okay, anyway, basically ang problem lang naman dito, ika-calculate nyo rin lamang yung time for washing. So ika-calculate nyo lamang yung rate of washing, dV/dt is the rate of washing using this formula. And then, pag given yung volume, no, given yung volume kung gaano karami yung ng liquid na iwawash nyo, you just basically divide, no, the volume with the rate of washing, and then you will get the time for washing. Okay, so this is for plate and frame filter. O kamukha nung sinasabi ko sa inyo kanina, pag lip filter, wala siya nung 1/4. Kasi hindi naman nagde-deposit yung solid dun sa lip filter. 'Di ba? So, pag nag-wash kayo, para din lamang kayong nag-filter. Malinaw ba 'yon? So that's why the rate of washing is the same as the filtration rate. 1/KPBF plus B. Do you have any question regarding these equations? So kung wala, let's try to solve our last problem. At saka ito pa pala. Yung total filter cycle time, no? So kung natatandaan yung pinanood yung video, 3 yung component nun. First is you have the filtration time, no? Ipi-filter nyo muna yung slurry. Tapos kung kailangan i-wash, i-add nyo yung washing time. Tapos, kita nyo, di ba, binubuka yung mga frame para matanggal yung solid. Ang tawag dun is the cleaning time. So, i-add nyo pa yung cleaning time. Okay? Malinaw naman, ano? Question? So, let's solve the last sample problem. Problem number 3, example number 2. At the end of filtration cycle, in example number 2, a total filtrate volume of 3.37 cubic meter is collected in a total time of 269.7 seconds. So, yun na-calculate natin sa problem number 2. Ano? The cake is to be washed by thorough washing in plate and frame press using a volume of wash water equal to 10% of the filtrate volume. So, iwawash nyo siya ng 0.337 cubic meter. Calculate the time of washing and the total filter cycle time if cleaning the filter takes 20 minutes. Okay? Imagine nyo, madali lang naman, ano? So ito muna, mag-calculate muna tayo ng time of washing. So gamitin lang natin yung formula. This is a plate and frame press. So pag plate and frame press, ang formula lamang ng washing rate ay dV/dt. Ito yung washing rate, ano? 1/4. Tapos 1/KP, tapos BF plus B. So, kung tandaan nyo pa yung mga values natin kanina, substitute lang natin, ano? So, 1/4. Yung KP natin kanina is 39.09. O, di ko pa dito. KP is 37.93, ano? 37.93. O, bahala na kayo sa unit, ha? Seconds per meter to the 6. Ilagay ko na rin. Tapos multiply nyo ng BF. Ito yung BF natin, ano? 3.37. Final volume of the filtrate. BF, final volume of the filtrate. 3.37 cubic meter. Tapos yung B na nakalculate natin kanina is 16 something. 16.09. So ito naman ay 16.09 seconds per cubic meter. So pag kinuha niyo yung reciprocal nito, ang magiging unit nito ay cubic meter per second. That's the rate of washing. Diba? dV/dt, the rate of washing. Okay? So ang magiging unit ay cubic meter per second. Okay? Get your calculator. Calculate the rate of washing. So 1 divided by 4 times 1 divided by 37.93 times 3.37 plus 16.09. Okay lang? So what do you got? Yeah, you're supposed to get 1.74 times 10 to the minus 3. Very good, QC. Manalon. Very good, Paolo. Ano? 1.737 times 10 to the minus 3. 1.74 times 10 to the minus 3. So ang gagawin nyo lamang, kasi di ba 10%, ano, yung filtrate volume, yung washing. Yung washing volume, ano, 10%. So ang i-divide nyo lamang to, 3.37 times 10%, no, this is in cubic meter. Ito yung washing volume, ano, so i-divide nyo lamang siya ng filtration rate. 1.74 times 10 to the minus 3. This is cubic meter per second. So lalabas dito yung washing time. Diba? So do that. 3.37 times 0.1 divided by 8. Tapos answer. So ilang seconds yung lumalabas? Yep. 193.68 seconds. 194 seconds. Very good, Gio. Very good dyan. Mga 194 seconds. Ano? Ito yung washing time. So how do we now let's try to calculate the total filter cycle time. Ito, total filter cycle time. Anong formula ng ano, total filter cycle time? Total filtration cycle time. Basically, add nyo lamang yung filtration time plus yung washing time plus yung cleaning time. No? So, add lang. Halimbawa, itong filtration time, 269.7 seconds, plus yung washing time, 194 seconds, plus yung cleaning time, 20 minutes, so times 60. No? Yun, ganun lang. Ano? Kung gusto nyo in minutes yung unit, so all over nyo ng 60. All over natin ng 60. Okay, so get your calculator. How many minutes yung cycle time? Tapos divided by 60, ha? So how many minutes? Yep, very good, Paolo. 27.73 minutes. 28 minutes, that's also good. Very good, Gio. Kasi may correct, 27.73 minutes. Nasundan ang ating lecture for today. So, yun. You're supposed to get 27.73 minutes. Final answer. Ano? Yung washing time is 194 seconds or 193 point something. Do you have any question regarding the three problems? So, nakalagay naman dito sa ano yung solution. Ano? Ganun lang naman. Ano? Calculate nyo lang yung washing rate, tapos divide nyo lamang yung total volume ng washing rate. Tapos total filtration cycle time, sabi lang punta. Question. So if you don't have any question, I have 3 exercises for you. Lalagay ko sa BBL later. So this one, the first one is about calculation of alpha and RM. Kamukha nung ginawa natin sa problem number 1. And you have another exercise. This one is filtration time, calculation of filtration time ata. Anda na. This one is ano, parang total filter cycle time, tsaka time of washing. Okay, lalagay ko rin yun later. Tapos another one, another problem. This is a lip filter. So solve nyo itong tatlo. Ano? Lagay ko sa BBL later. 11:28. Check lang ako ng attendance, ha? May 2 minutes pa naman ako. Parang sikagin kayong umattend. Although matatapos na yung klase natin. We'll have our last meeting on Wednesday. Siguro discuss ko yung isang membrane set pa, yung heart and lung machine. Ano? So we'll meet on Wednesday. Tapos, probably walang pasok ng Friday kasi People's Power. Okay? Sana ma-realize naman ng mas maraming tao na almost miracle ang EDSA. Nasasayangin lang nila. Miracle talaga yung EDSA. Ako tingin ko miracle yan. So, anyway. Yun yung decision na nakakarami. Wala tayong magagawa. Kung sakasakali. Okay, Nikki.
Present po. Present.
Christiana. Aphrodite.
Present po, sir.
Shanlane Barbastro. Shanlane. Jose Marie Bileno.
Present po, sir.
Very good, Jose. Teresa Paula Borlongan. So basically, we'll have our midterm on Monday. Ano? That would be 28. Yeah, announce ko naman. Lagay ko sa announcement. Vanessa Buen Consejo.
Present po.
Patricia Sophia Capola.
Present po.
So itong dinidiscuss ko ngayon, pang-finals na to, ano, together with membrane sep and adsorption. Dominic Centeno.
Present po.
Princess May Ceres.
Present po.
Dane Kimberly Collado.
Present po.
John Limuel de los Reyes.
Present po.
Kian James Francisco.
Present po.
Kyle Terence Xavier. Kyle. Bea Lambino. Jamila Lim. Angela May Llames. Alexandra Lusterio.
Present po.
John Paulo Maseren. Paulo.
Present po, sir.
John Paul Manapat.
Present po.
Okay. Evelyn Manriquez. Si Evelyn. Kissy May Pedrosa.
Present po.
Okay. Christine Joy Pelicano. Christine Joy. Chelsea Petarial.
Present po.
Angela Nadine Piconada. Miss Piconada.
Present po.
Cedric Jan Kikay.
Present po, sir.
Vicky Marie Kilo.
Present po.
Aina. Ay, wala. Ezekiel Resurrection.
Present, sir.
Ian.
Present po.
Kim Sangab.
Present po.
Okay. Raira.
Present po.
John Rex Tadena.
Present po, sir.
Emmanuel Tixon.
Present po, sir.
Gio.
Present po.
Christopher Tuason.
Present po.
Chelsea Biado.
Present po.
Roma Villas. Roma. Kisha Biliana. Angelica Yap.
Present po.
Okay. So see you on Wednesday, no? Okay, so on Wednesday we'll try to discuss the heart and lung machine. It's a type of membrane separation process. Oo, upload ko. Mamaya sasabay ko doon sa video, Christopher. Okay, do you have any other concern? Okay, kung wala, so see you on Wednesday. Hindi. Ano to? Ang midterm natin ano lang? Distillation lang. So sa finals na to. Okay? Ano pa? Okay, so wala na. Bye-bye. See you on Wednesday.